Private IP addresses, public IP addresses. Well, how do those work together on the internet? Well, we're going to talk about network address translation next, right here on IT Pro TV.
You're watching IT Pro TV.
That's true. It is not the Saturday Night Live skit that you were hoping for, but instead we are going to talk about network address translation and port address translation, and here to help us to clarify everything that we need to so we can see it crystal clear, whether it's actually Pat or Nat, Anthony Sequeira. All right, so Anthony, as we start here, this doesn't seem like, to me at least, CCIE level information that we're doing.
Yep.
But it seems like something that we have to know.
Yeah.
Okay.
This is an area where, at the CCIE level, I remember bogging down a little bit with this because there's so many possible NAT configurations. You know, the concept of doing it unidirectionally versus bidirectionally. Are you doing source address or, destination address translation? It can get really, really messy. Fortunately, here at the Encore level, it's almost like a review of what you taught in CCNA, Ronnie. We'll focus on inside source address translation, and we'll do it dynamically with a pool, or we can, of course, discuss how we would do it with just an interface and overload that interface IP address. But let's just get in and review some of this. And one of the major things that I want to review is the terminology. That's important.
Right.
And that's what tends to really confuse students, that inside local versus inside global, outside local versus outside global, what's going on there? So let's jump to a router. We'll go to the R1 device. Notice I pick on R1 here because it's in a good spot. It's in the middle of this topology. And Ronnie, if we took like one of the loopback addresses coming off R4 and we sourced traffic and we tried to get over to the R5, couldn't we do translation right here on R1 of any of that source information? Sure. So let's try and do that. So here on R1, remember when it comes to your configuration, one of the first things you would be thinking about would be, okay, what interfaces are you going to be involving in this scenario? What's your inside NAT interface and what's your outside NAT interface? I've actually seen a lot of people configure this the opposite way.
Right.
They don't touch the interfaces until they've got the NAT instructions in. I don't really care what approach you take as long as you get this configured consistently correctly. We'll do the interface configs first. Yep. I'm going to go in. I'm already in global configuration mode. I'm going to say interface gigabit 0/1 IP NAT inside. And there's a delay as my router crashes. Never good. Wow, that's pretty interesting. We'll keep going and see if it actually works or if it's going to even let me finish the config. Now I'm going to interface gigabit 0/2 IP NAT outside. It doesn't surprise me that the router hiccuped a bit there because when you do the NAT config, you are changing quite a bit about how the router is going to operate and how it's going to behave.
Yeah, there's no doubt that when we start doing this, my suggestion is pick a way that you're going to do it and be consistent with it. So if you're going to configure the interfaces, don't configure the interfaces at the end one time and then at the beginning on the next router if you're actually going to do it.
Such great
advice. Keep it the same, because if not, you'll go through I always like to do this the same way, and then I configure, I go, all right, I've done the hard part now, I'm done. So that's what I always think about. But
yep.
I know if I configure the hard part and then forget to configure the interfaces, I'm toast.
Yep, you definitely use that methodology, get it nailed home like muscle memory, and then that's how you do it. I love that advice, Ronnie. A lot of times, if I've got to configure something that's really deep and involved, I will break it down in OSI layers. Yeah. Have you ever done that? Where like, okay, let me do the layer 2 first, then the layer 3, then the layer 7, and then I'll do it in that order every time. And it helps you not to miss a step. It helps you reduce the amount of troubleshooting you have to do. It's really good practice, Ronnie. So let's jump back in here. We've given the IPNAT inside, the IPNAT outside. Then what you do is you construct your instructions on how the NAT's going to work. And we often use an access list. In fact, I'll just say access list. We often use like 1, and you say permit, and then what it is that you're going to be translating. If I go down to R4 and I do a show IP interface brief, we will see that we have some loopbacks down here. How about this 70, 70, 70? All right, great. I'll go over here to the R1 and I'll say 70.70.70.0000255. And so now we have an access list that is defining, listen closely, the inside local addresses that we are going to translate. And this is interesting because you look and you go, well, wait a minute, 70, that's part of the public IP space. Aren't you supposed to be doing this with RFC 1918 addresses? Well, yeah, you typically would, but there's no requirement that says that. You can NAT anything you want. You could be merging with another company, Ronnie, right, and you're both using the same RFC 1918 address space. So now you'll be doing NAT in one of the directions from RFC 1918 to RFC 1918. There are no set rules here on how or why you would do network address translation. Keep that in mind. So I have an access list, and it is identifying the inside local addresses that we want to translate. And what are we going to translate them to? What's the inside global addresses that we're going to translate to? Well, you could do a pool of addresses, or because we want to review port address translation, let's do a PAT configuration. So I'm going to do IP NAT, and then I always use context-sensitive help here because there's so many options. We want to do inside address translation. We want to do the source address. We have a list, access list 1, that we specified for the inside local addresses. And no, we're not translating against a pool we could have set up. We're translating against an interface. It's the gigabit 0/2 outside interface. And notice we can overload. So that keyword right there triggers that port address translation behavior. And now all these different inside local addresses can get translated to that one address. Ronnie, how does that work? How is that possible? How could all these different source addresses get that one inside global?
Yeah, it comes down to what we call it port address translation.
Gotcha.
Yeah, ports.
So just remember, PAT stands for port address translation. We're going to add some port numbers.
Right. Yeah, so this is a very interesting concept here, right? So the keyword, you've got to make sure that at the end of it has overload. So if you get the entire configuration correct, you get all the inside, outside, you get the access control list, you can get the syntax right, you miss overload, it will not work the way that you think it's actually going to work here. So can that actually happen? Very quickly, especially when you think you need to work very quickly to do that. And then when you even go through the show commands, or you actually run through the show run, and you look at it and you just miss seeing that word overload,
yep,
that's enough to stop it.
Yep. So
yep,
testing this is always interesting. Like, that gets a little challenging. Mm-hmm. It's almost tougher to verify than it is to configure. I mean, think about it. We set this up for the translation of the 70, 70, 70 source addresses. So, all right, we would generate some traffic sourced from that loopback. Well, we know how to do that. Can this device even get up to the R1 device where we want to do the translation? I don't know. Let's see. Well, that looks good. It looks like we can reach that destination. And in fact, I think we have full reachability in this topology. That's good, because that would be necessary. So let's try it. Let's see if we can trigger some translation. Let's do a ping for 192.168. Before we do anything fancy, let me just see if I can ping all the way over to R5. That would be through R1, 192.168.0.5. Good, I can. All right, so we'll try that again, but we're going to do a source of the 70.70.70.70. And I'm thinking that just triggered some network address translation, unless that router crash that we saw is making this not work. Show IP NAT translation.
You're on router 2.
Wrong router. Thank you,
Okay.
Ronnie. That's why we love teaching together. So there you can see I did show IP NAT translations a moment ago, and there was nothing. That's because we had just configured the feature and we didn't run any traffic through it. Look at that. We've done some network address translation. You want to read this from the left to the right. It was the ICMP protocol that just happened to trigger the translation. It was the inside global of 10.0.0.9. Show IP interface brief. Look at this. It was the Gigabit Ethernet 0/2, which we said to overload. So it did that, and it went and appended that port number of 2, Ronnie, to give the uniqueness there. The inside local was 70.70.70.70 that got translated into the 10.0.0.9. And then you can see the outside local and the outside global, and you see there was no translation there. Those two are identical IP addresses. By the way, there's a really handy trick that I always use on memorizing what addresses what address, and it works out great when you have RFC 19 addressing that you're translating to get out to the internet. I always think of the RFC 1918 address as crazy. Those crazy 1918 inside use only addresses. And I think of Spanish, loco.
Oh, okay.
In Spanish, loco means crazy. So the inside loco is usually an RFC 1918.
Right.
And the outside loco is usually a 1918 address. So that's one way that's easy to remember that. The inside local is typically the RFC 1918 that you're translating. How that would be reached from the outside world is typically that address. So it works out great. The inside global, think internet when you hear global, is typically an internet reachable address, as is the outside global, as is typically internet reachable. So that's an easy way to remember that, Ronnie. But again, doesn't work in our example here because we're not doing the classic RFC 1918 translated to internet.
Yeah, you say that. I found this particular terminology to be one of the most confusing things that we teach at the CCNA level to try and get people to understand the way that it actually matches up. But notice what Anthony did here, right? Is actually group the locals together and then group the globals together instead of the way that you normally hear, like, let's go from, to actually do this. And then people are confused, like, why am I translating inside to inside and then translating to outside? It doesn't seem to make sense to them. So it's just one of these things. You just have to get used to terminology because you're going to see it in every exam that you ever take.
That's right. That's right. And I heard it described a really great way, Ronnie. It was like the inside local is the address that the other devices on the inside network would see that device as, right? And the outside local is the same thing. So that's a neat way to describe it. And then the inside global address is that inside address as it would be seen from the public internet.
Right.
So there is simple explanations of those.
Now, Anthony, if you run the show IP interface brief, I believe that we end up seeing that it also created another interface, if I'm correct.
Oh, yeah, it's right here. Look at that. The NVI 0.
Okay, yep. So that's actually one of those things that can tell you whether or not, as you're looking at this, whether or not NAT has actually been configured, even if you don't get the commands to be able to see that in the show run. Hey, is NAT configured on this device? Well, simply by running this, you can tell whether or not it's actually been configured.
Yeah, and I suppose we could have looked at that. There's been a NAT timeout, right? So now the NAT translation is gone.
Right.
There's another thing that we could do that would be fun here, and this won't take long. Let's do this. Ronnie, what I'm going to do is I'm going to add, we have time, right? Yeah, we have time. I'm going to add loopback 700, and I'll say IP address will be 70.70.70.71. You see what I'm going for here. Yeah, I can't do this on the same router. What was I just thinking? Oh, darn it. We could have done this where I did translations of anything that begins 70, right? With the 8-bit scrutiny. You see what I'm doing? You could do this in a way where you could configure multiple addresses that are going to be translated, and then you can fire off traffic from those, and you can test the overload feature.
Right.
Where you can literally see all these different addresses being able to be translated.
Yeah, and that confirmation that we're normally looking for what Anthony was trying to show here is when we do that show IP NAT translations, what you'd see is the incrementation of the port numbers on that inside global as you did. So even if it was the same IP address and Anthony continued to issue pings, you would continue to see the port numbers actually increment is what you would actually end up seeing. And that would be the same thing because that actually is showing you the different streams of traffic that's coming from those devices as well. So that's how they actually kind of individualize and be able to put stuff back together.
Yeah. And I just realized I can do that demo, right?
Okay,
Can I go to R2 and do a 70-70-70 on R2?
Yes,
Yeah. I got multiple routers here. Let's do it real quick. Why not? So here's R2, where I did the incorrect show IP NAT translations earlier. We'll do this. We'll do interface loopback 77. I'll do IP address 70.70.70.72. And we will show you what we were talking about. So I'm going to do a ping to 192.168.0.5. I'm going to source it from our loopback 77. And I'll even do, let's see. Yeah, we can do a repeat of 20. So there we go, a whole bunch of ping traffic. We're going to slide over to the
R1?
R4 device.
R4,
because remember, we want to do some more.
Oh, yeah, that's right.
There we go. Now it's not working. That's interesting. And if we go over to R1 and we do our show IP NAT translation, look at that. We are getting the translation overloaded.
Yep.
And we can see the different port numbers, just as Ronnie said we would see, to distinguish the two different inside locals that are being translated.
All right, Anthony. Well, thank you for kind of helping us to understand the idea of NAT and PAT translations here. Remember that we normally typically see it with RFC 1918 addresses going out to the internet, but he did tell us that it doesn't really matter. There's no real restriction that it always has to be private IP addresses to public IP addresses. Here he showed us an example of using port address translation and how we can actually test that as well. Keep in mind those show commands. Those are actually going to be very helpful for you as you continue on for your Encore exam as well. Well, that does it for this particular episode then. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.